assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
We can first use equation 1529 and the parallel axis theorem. Where we can say that the moment of inertia would be equal to the moment of inertia through the center of mass plus mh squared, where here h is equaling d. D is what we're trying to find. For a meter stick of mass m, the rotational inertia about its center of mass, I sub cm, would be equal to ml squared over 12, where the length of the meter stick is, of course, 1 meter. So we have a period equaling 2.5 seconds, and we can obtain that the period is equaling 2 pi multiplied by the total moment of inertia, ml squared over 12, plus md squared. This is going to be divided by mgd. Here, then, we're going to count all of our masses, and this is equaling 2 pi multiplied by L squared divided by 12 GD plus D over G. And essentially, we're going to plug in all of our constants, 2.5 seconds. L is equaling, of course, 1 meter. And then we can, just to confirm, G is the acceleration due to gravity, 9.8 meters per second squared. And then you can use your TI-84, 85, or 89 in order to essentially answer for D. So we can simply solve and then simply solve by plugging in all of our variables and then solve for D using the solve function. D is going to equal 0.056 meters. This would be our final answer. That is the end of the solution. Thank you for watching.